Hey, welcome back. In the last video, we began our discussion of the American Association of Medical Colleges foundational concept number 3, more specifically the endocrine system and how that functions in our body's ability to achieve and maintain homeostasis. So I left you with a layout of the main endocrine organs here on Mr. Vitruvian. And so if you're not really clear yet about where those organs are located, or you don't feel comfortable with your big picture understanding of what the endocrine system is, I would definitely encourage you to either watch or rewatch that first video. But today I want to go into a little deeper understanding of what exactly a hormone is. And so we called it a chemical message, but let's clear that up a little bit, because when it comes time to memorize individual hormone names, or as those names get really long and exhausting, hopefully we'll be able to build associations with how they work. And so a hormone, again, is a chemical released by an organ, maybe a gland or even a cell, that affects another part of the organism. And so some examples of those effects that hormones cause might include metabolism. Metabolism is really important as it relates to how our bodies get energy. And so another effect that hormones cause is, or another effect that hormones control rather, are blood levels and fluid volume. And so how much glucose is in our blood, or how much calcium is in our blood, or even for that matter, how much blood is in our blood. Those effects are controlled by hormones. And so another effect, maybe the stimulation or inhibition of growth. And so we'll see later as we talk about the pituitary gland and growth hormone, how hormones initiate growth in our bones and in our muscles. Movement between life phases is an effect that hormones cause, like puberty, taking our body through puberty and through menopause, and even controlling the body through states of mind like hunger and fear. And there are many more effects that hormones cause, but I just kind of want to get your brain rolling as to these effects that we see in our bodies, but they're actually caused and initiated and maintained by these little chemical messages traveling about, called hormones. And so here I've drawn a pretty admittedly a poor drawing of a hormone leaving a cell, but hopefully this drawing can give you a visual for these chemicals being made by a cell, and then being released from that cell through exocytosis in order to travel throughout the body, through the blood, to affect another location. But what kind of chemicals are we talking about? Because that's just a little generic yellow chemical. But inside of our bodies, we've got proteins and lipids and carbohydrates and a lot of different chemicals. And so it turns out, let me scroll down, that there are 3 main types of hormones in humans, and they differ in the type of chemicals that they come from. And so for starters, we've got peptides. And peptides come from proteins, so they're composed of amino acids. Amino acids are the building block of proteins. So peptides might be small and made up of only a few amino acids, like ADH, which is Antidiuretic Hormone, or sometimes called vasopressin. Or they might be really big, like insulin. Insulin is a kind of a giant peptide hormone. It's many amino acids big. And so because they're made up of amino acids, peptides are charged or polar. And so I know that assumes some familiarization with amino acids, and I'm super sorry if it confuses you. Definitely feel free to take a second and look up what an amino acid is, why it's charged. But because they're charged, peptides can't cross membranes, and so their receptors are typically on the outside of cells. So the next big type of hormone in humans are steroids. And steroids come from lipids, namely cholesterol. Cholesterol is a big lipid. And so because steroid hormones come from cholesterol, which is nonpolar, steroids are nonpolar, and they're able to cross cell membranes. And so typically steroid hormone receptors are on the inside of cells, and might even be in the nucleus of a cell. And so those are steroids. Next up, the last main type of hormones in humans are monoamines. And monoamines, they're not quite as common. There's kind of a subcategory of monoamines called catecholamines, which a lot of us have heard of epinephrine and norepinephrine in our kind of flight or fight response system, but monoamines are altered amino acids which are usually attached to a benzene ring for you organic chemistry buffs. And so monoamines can be polar or nonpolar, and that allows them to possibly act like a peptide. Epinephrine, like I just mentioned, as a monoamine acts like a peptide, or steroid. They might act like a steroid. And so the thyroid hormone thyroxine, which is T4, is a monoamine that acts like a steroid. But the chemical nature of a hormone is really important because the structure and function of these chemicals and where their receptors are located play into how they function within our body. And then, as we learn about how they function, that'll help us understand and better be able to kind of utilize that information. And so if a hormone were to act like a peptide, let's say insulin, and its receptors on the outside of the cell, it's going to act really quickly because that hormone can travel through the bloodstream and it gets to the outside of the cell pretty quickly. And so, for example, patients in the hospital that I've seen respond very rapidly to insulin injections. I've seen someone go from having a pretty critically high blood sugar, like in the high hundreds, just for a baseline for you. The kind of normal there is 80 to 120 typically for blood glucose level, blood sugar levels. But I've seen them come back to baseline pretty rapidly through insulin injections. And that's because insulin is a peptide hormone. Its receptors on the outside of cells, and they act really quickly. What if the hormone acts like a steroid, though, like that thyroid hormone T4 that I mentioned, which is a monoamine that acts like a steroid, and its receptors in the nucleus? Well, that hormone might initiate a change in transcription, which is super slow to onset and might, last a really long time. So, for example, it might take months before you see the effects of giving a patient that has hypothyroidism or low thyroid hormone levels replacement therapy, because that's a long initiated cycle that begins in the nucleus and alters transcription and translation. And so being able to ask yourself questions like that as you study, it not only takes you from passive learning to active learning, but it can really help develop your scientific reasoning and problem solving skill, which is a really important skill that the AAMC expects of you. And so I can't tell you how important it is as you study for the MCAT to generate and maintain and encourage your own curiosity, because there's nothing that's going to be more helpful than moving past memorization into a real grasping understanding of these concepts so that you can critically think through them on a standardized pre-health professional test and in your future medical career. So I definitely find understanding to be a lot more fun than memorization. So anyway, next up, we're going to talk about the control center of the endocrine system, which is the pituitary and hypothalamus, and I can't wait. But hopefully now you've got a little bit of an understanding of what a hormone is, and when it comes time to memorize a whole bunch of them, maybe now you'll be able to kind of draw a connection in your head between how they function, and that'll give you kind of that tangible grasp on it. So anyway, I enjoyed it, and I'll see you in the next video.